Aside from those Punnett squares themselves, we want to be able to interpret this data and use it to predict what might happen. So that's where the probability comes into play. So probability is the likelihood that a particular event will happen. For us, we're trying to predict what the offspring might look like, and so we're going to use probabilities from our Punnett squares. But we're also going to have to understand that just because you can predict that something is going to happen does not mean that it's definitely going to happen. It just means it's likely to happen when you're talking about probability. So this first question here, the probability of flipping a coin and getting a head is going to be 1/2, right? There's only heads and tails. There's only two options, so one in every two flips, you should get a head. But that doesn't mean that that's always going to work. If you flipped a coin 10 times, you would expect that half of those flips would end up being heads. So you would expect to get 5 heads. But that's not necessarily going to be true, but that's what you would predict. So we're going to start out and we're going to do some different probability questions, and you're going to make a prediction. Although that may not end up being true, it'll give you a good idea of what you should be looking for at the end of the day. So the first kind of question is this one here. If you flipped a coin 10 times, how many heads would you expect to get? Most of us knew that it was 5 anyway, but you need to understand how to do the work so that you can get that answer every time. So how you're going to do this is you're going to use those fractions given to you as probabilities, and you are going to multiply them by the number of times you're going to do it. So I'm going to flip the coin 10 times, and half of the time I'm going to get heads. So 10 times 1/2, it gives me 5. Because it was 10 over 2, divide that, you get 5. So I expect to get 5 heads. But it's different if I ask you for individual events, right? Because I could expect 5 heads, but it's really hard to get 5 heads in a row, right? So I also have other kinds of probability questions. What is the probability of getting heads 3 times in a row? That's going to be a different kind of question, but it's also fairly simple to get at the end of the day. For each individual event, you get a probability of 1/2. So if I multiply 1/2 times itself 3 times, that should give me my answer. So if you're asked a question like that, what's the probability of getting heads 3 times in a row? You take 1/2 times 1/2 times 1/2, multiply the tops in that fraction, you get 1. Multiply the bottoms, 2 times 2 times 2 is 8. So I have a 1 in 8 chance of getting 3 heads in a row. And you don't really have much option. You just kind of have to write out a long label there. Right? There's a 1 in 8 chance of getting 3 heads in a row, so that's how you solve a question like that. So I used coins because it's something that you guys are familiar with, but we're not flipping coins. We're trying to figure out what's the probability of getting a trait, right, passed on from parents to offspring. So we're going to use real data examples for this. The probability of getting a white flower in Mendel's F2 generation was supposed to be 1 in 4. Remember, there was a 3-to-1 ratio. And a ratio is not the same as a fraction. 3 out of the 4 were purple, 1 out of the 4 were white. If you actually look back at the Punnett square for that, one of the 4 squares had that white trait in it. So you're always going to have a fraction that looks something like that. But if 1 in 4 are going to be white, and there were 80 plants in said generation, how many would you expect to be white? So you're going to do the same things that I did with coin flips, right? If I did this 80 times and the probability of getting white was 1 in 4, there was a 1/4 chance. I multiply those two things, and that should give me my answer. So you end up with this 80 over 4 for your fraction, since this could be a fraction here. Top times top is 80, bottom times bottom is 4. Divide that, 8 divided by 4 gives me my 2, so it's 20 white flowers. If I had 80 plants, I would expect 20 of them to have white flowers. Now that being said, 20 of them probably more or less will have white flowers, but it could actually be 23 of them. It could be 16 of them, but it's probably going to be somewhere close to that 20. That's what a probability gives you, right? I can say probably 20 of them are going to be white. Okay, and then the other question I'll ask you, and I'm basically asking the same questions over and over again, so don't get too freaked out by this. But I'll say, what is that probability? You're walking through that garden, you pick 3 white flowers at random while blindfolded. What's the probability that you pick 3 white flowers in a row? So again, if you see that in a row, I want you to think probability times itself, however many times you need to do it. So if the probability was 1 in 4 for one try, it's going to be 1 in 4 for every try. So you just take 1/4 times another quarter times another quarter. And again, 1 times 1 times 1 gives me that 1 on top. 4 times 4 is 16. And 16 times 4 gives me 64 for that bottom part of the fraction. So the probability of me picking 3 white flowers in a row is 1 in 64. So I have a 1 in 64 chance of picking 3 white flowers in a row. So again, I'll do a lot of problems like this, and I'll ask you to use those probabilities to come up with an answer. If I ask you how many are you going to end up getting for whatever trait, all you have to do is multiply by your probability. If I ask you what is the probability of doing that 3 times in a row, you got to multiply the fraction times itself 3 times. Right? And I might say 4 times in a row, or I might say 2 times in a row. Right? So it's not always 3 times, but generally speaking, I'm not trying to make it difficult for you guys, so I'm going to do pretty much the same thing. So if you got all that, we should be able to do what we need to do.